Everything we see in the world is made out of stuff, and it is called matter. Everything, even the universe, is made out of it. Well, except light, because it is a form of energy. But what is matter? What are the differences between the states of it? And the most important question is, does it even matter? You get that, right? As I mentioned earlier, everything is matter. The water that you are drinking, the device you are using to watch this, your pet, whether it be a dog or a lizard, and you, yourself is made out of matter. Given all of this, what is the exact definition of matter? Matter is made out of atoms, and the unique formation that they are in is called a lattice. Matter is defined as anything that has mass and takes up space, which means it has volume. Mass is simply the amount of matter present on an object, while volume is the amount of space that an object occupies. For example, imagine pouring your favorite drink in a glass. The space that it takes up in the glass is the volume. Everything in the universe is considered matter, for they all have mass and volume. Now, we already have an idea of what is exactly matter. Let's move on to its different states. The solid, liquid, and gas. Imagine a boy holding a cup filled with bubble solution. He blows air onto the bubble wand, which forms the so-called bubbles. These are all the different states of matter. The wand being solid, the solution being liquid, the air you blow being gas. Different states of matter behave differently for their individual properties. The states of matter have tiny particles which cannot be seen by the naked eye. Now, let's move on to the different states of matter themselves.
Whoa! So let's talk about solids. The particles of solids are packed together and barely have any spaces between them. The particles are what made the shape of the solid defined and make it harder to compress. It is possible to compress solids, but it requires enormously high pressure to be able to do so. At high temperatures, solids barely expand, and they are also known to have high density. The second state of matter is liquid. Unlike solids, the particles of liquid are not as packed like on solids. It is not closely bounded, arranged, and fixed in place. It is only compressible if it is in a container. The particles in liquid can flow freely and can mix with particles from other liquids, for it has spaces between them. Liquids have an indefinite shape, for they only take the shape of the container holding it, because of its particles being randomly arranged. You might have experienced spilling a glass of water when you put too much. This proves the statement that liquids take up the shape of the container they are in. If it exceeds the volume of the container, the excess water will become shapeless. It expands slightly at higher temperature, and it has medium density compared to the solids. Sometimes matter cannot be seen, but you know it is there because you can feel it. This state of matter that we speak of is gas. It is everywhere surrounding us, but the question is, how is gas a matter? Does it occupy space? Does it have mass? Well, imagine a balloon without gas inside of it. It is just a flat rubber with nothing in it, but when you fill it up with air, it fills up all the spaces inside the balloon, which means it has volume. The particles of gas are much different from the first two states of matter's arrangement of particles. They are far apart from each other and arranged in a random way. This is the reason they have indefinite shape and indefinite volume. They are compressible, but just like solids, they require a high amount of pressure to be able to do so. It greatly expands at high temperature, which is why some gases explode when exposed to immense levels of heat. In addition, plasma is also considered as a state of matter, but it cannot be found anywhere here on Earth. Now to recap, here is an informative table on everything we just discussed in the past few minutes. Now we are enlightened on what are the states of matter. Now it is time to dive into the compositions of matter. Compositions of matter are made up of substances. Substances are the definite and constant composition of things. They also have distinct properties. It can be identified by our different senses: sight, smell, hearing, taste, and also touch. Substances are divided into two. These are the elements and the compounds. An element is a species of an atom that contains the same number of protons, while a compound it is not a place where lots of houses are built, but rather, it is a mixture containing two or more elements that are chemically united. Mixtures themselves are also divided into two: heterogeneous and homogeneous. Homogeneous is uniform and only has one phase, while the heterogeneous mixture is not uniform and consists of two or more phases. Let's talk about density. The mass and volume are extensive properties, while the density itself is the intensive property. Intensive properties are the ones that don't change on the amount of material present, while the extensive properties are the opposite. They depend on the amount of material present. Now let us get into the properties of matter.
That's a good one, John. Now, back to the properties of matter. There are two types: physical and chemical. A chemical property is any of a material's properties that becomes evident during or after a chemical reaction. It can only be changed by a chemical reaction. On the other hand, a physical change is observed with a change of identity. It only changes the appearance or state of the object. Example is freezing of water or tearing of paper. Now, back to mixtures. There are various ways of separating mixtures. First is filtration, which is used to separate a solid from a liquid in which it is suspended. It is used when one is insoluble and the other one is soluble. The second one is evaporation, which is great for separating a mixture of a soluble solid and a solvent. The process involves heating a solution until the solvent evaporates, leaving behind only the solid residue. The third one is simple distillation, which is best for separating a liquid from a solution. It seems like evaporation, but the vapor is collected by condensation. Example is separating water with salt. The fourth one is fractional distillation, which is separating two miscible liquids or liquids that dissolve each other. And the last one is chromatography, which is used to separate mixtures of the substances into their components. And that is all for today's episode of Nicomedes. Now you've understood the basic parts of chemistry. See us next episode regarding of measurements and Dalton's atomic theory.